Welcome to this video on evaluating algebraic expressions. Let's begin. Algebraic expressions cannot be solved since they do not contain an equal sign. However, they can be evaluated if values of all the variables they contain are supplied. So let's look at this example, 3x plus 5. There's literally nothing we can do. 3x and 5 are not like terms, so we cannot combine them in any meaningful way. We cannot do that. There's not an equal sign there. For example, if it said 3x plus 5 equals 2, we could try to solve it, but it doesn't. So there's no way to simplify it. There's no way to solve it. Nothing can be done. However, if I give you some information, if I say, hey, 3x plus 5 and x equals 4, now I've been given a value for 4. Now I could evaluate 3x plus 5 at x equals 4. So what does that look like? 3x plus 5. Okay, if x equals 4, that means wherever I see an x instead of x, I'm just going to write a 4. And just as always, I always have to observe and honor order of operations. Right? Please excuse my dear Aunt Sally. So that means I'm going to have to multiply 3 times 4 before I add the 5. So I would get 12 plus 5, or 17. So again, if you just have an expression and nothing else, there's nothing you can do. If you have an expression and a value for all of the variables it contains, then you're able to evaluate that. So let's get started on evaluating algebraic expressions. So this one says evaluate parentheses x plus 3, close parentheses, plus 10 if x equals negative 5. So wherever I see an x, in place of x, I'm going to write a negative 5. So I have parentheses negative 5 plus 3, close parentheses, plus 10. Remember, please excuse my dear Aunt Sally, tells me that I have to do the parentheses first. So negative 5 plus 3 is negative 2. If you'd like, you can keep it in parentheses. You certainly don't have to. So then you have negative 2 plus 10, and of course that gives you 8. So that's the answer to the first expression. Let's do another one. This time we have x parentheses 2 plus x, and we're told that x equals 4. So once again, I'm going to write out 4 in a different color. So I have 4 parentheses 2 plus 4, close parentheses. Again, honoring, please excuse my dear Aunt Sally, order of operations. I have to do the 2 plus 4 first because that's in the parentheses. And then the implied operation between the 4 and the 6 is multiplication. So we get 24. Let's keep going. Evaluate 5x plus 2y if x is equal to negative 2 and y is negative 3. So wherever I see an x, I'm going to write negative 2. I'm also going to enclose it in parentheses just to preserve the operation between the 5 and the x, which is supposed to be multiplication. Hopefully you guys can see that. And then for the y is negative 3. And again, I'm going to enclose that in parentheses to preserve the operation of multiplication. So we have 5 times negative 2 plus 2 times negative 3. So again, be careful here. Even though both of those numbers are negative, we're not adding or subtracting, right, to the coefficient. We're multiplying. 5 times x is 5 times negative 2. So 5 times negative 2 is negative 10. 2 times y, that's 2 times negative 3, which is negative 6. So I have negative 10 minus 6, and that is negative 16. All right, next one. This time we have some fractional values of our variables. So in this problem, we're told that x is equal to 2/3. Again, I'll put it in parentheses just to preserve the operation of multiplication. And then we're told that y is negative 1. So we have 3 times the quantity 2/3 plus 8 times negative 1. Now, if you need to, you can always go back and review how to multiply fractions. If it helps you, you can write 3 as 3 over 1, and that might remind you that when you multiply fractions, we multiply across. So the top is 3 times 2, which is 6. The bottom is 1 times 3, or 3. And of course, 8 times negative 1 is negative 8. Then we can divide, right? 6 divided by 3 is 2. We have to divide before we add or subtract, right? Because please excuse my dear Aunt Sally. And then 2 minus 8 is negative 6. Okay, this time we have the quantity of x plus y squared if x is equal to negative 6 and y is equal to positive 4. So I'm going to write negative 6 for x and a positive 4 for y. So again, please excuse my dear Aunt Sally, we have to evaluate what's in the parentheses. So we have negative 6 plus 4, and that's going to be negative 2. Then we have negative 2 in parentheses, quantity squared. If you'd like to help yourself remember how to do this, we can rewrite this as a multiplication problem. Negative 2 quantity squared means negative 2 times negative 2. Remember, a negative times a negative is a positive, so this is positive 4. Okay, similarly, we have evaluate x squared if x is equal to negative 3. So sometimes people might want to write just negative 3 squared. Okay, and what you need to remember is that it's not just the 3 that's getting squared, it's the whole thing, which is negative 3. So very similar to the previous problem, we have negative 3 quantity squared. That's the same as negative 3 times itself, or negative 3 times negative 3. Those two negatives cancel out and give us a positive 9. All right, so at this point, feel free to start pausing this video, do these problems on your own, and unpause it to see if you're correct, because at this point you hopefully have sort of started to get the hang of it. And if this were a face-to-face class, I'd be making you do some of these on your own, or at least trying them before I went over them. Okay, so we have negative x squared minus 3x, and we're told that x is negative 2. So think about your signs. Okay, so one advice. One thing that I always tell my students, I'm like, hey, look, just go build a nest for yourself. Build a nest for the x. Okay, don't even write anything in there. Just put a blank set of parentheses. Okay, so notice that's what I've done. I have negative blank squared minus 3 blank. Okay, then go back and fill in your nest. Let that little birdie settle into the parentheses. Okay, settle into its nest. And now you can see much more clearly the order of operations. Okay, so I have negative 2 quantity squared. That is going to be a positive 4. Just this is a positive 4. But look, this negative sign, he's still hanging out there. He's still there. So when he comes down, it becomes negative 4. Okay, then I have a negative 3 times a negative 2. Negative times a negative is a positive. So this is going to give me negative 4 plus 6, and that's going to give me a positive 2. Again, take some time, go over this example. Come see me in office hours if you need to, if the signs are confusing you. That's probably the worst part of evaluation, where students trip up, is just dropping the signs, missing the signs, getting confused with parentheses. Okay, this one says, evaluate 45 over a minus 6 over b plus c if a is negative 9, b is 12, and c is negative 2. Okay, so I have 45 over a minus 6 over b plus c. So let's see, a is negative 9, and we're told that b is 12, and we're told that c is negative 2. And we can put parentheses here if we want. Okay, so from here, the order that you do things in is completely up to you. Well, that's not true. We have to, right, we have to divide. We have to do that before we add and subtract. Okay, so let's see what we can do with this here. So 45 over negative 9, we can just probably type that in our calculator or realize that it gives us negative 5. Now, what I was talking about when I said the order of operations is a little bit up to you is because we are going to end up with a fraction, right? So negative 6 over 12 reduces to 1/2, right? Negative 1/2. And then plus negative 2 becomes minus 2. And this is what I meant. This is where it gets a little bit tricky. Okay, so how are you going to combine these like terms? What do you want to do? You could probably move things around a little bit and combine the negative 5 and negative 2 first, and then try to combine that with a fraction. Or if that really frustrates and confuses you and you feel like you're abandoning your order of operations, what you can do from here is just change everything, multiply both the negative 5 and the negative 2 by 2 over 2 in order to get everything with the same denominator. So 2 times negative 5 is negative 10. So negative 10 over 2 minus 1 over 2 minus 4 over 2. Okay, and at this point, it's kind of weird that everything is negative, but that's how it worked out. But everything is going to be over 2, so we can just tally up the numerators, right? Negative 10 minus 1, that's going to be negative 11. Negative 11 minus 4 is negative 15. So that would be your final answer. Okay, so again, there might be other valid strategies that you might think of to do this. You might have done it slightly different from me, but at the end you should get negative 15 over 2. And remember, we try to always write our answer as an improper fraction. It is also equal to negative 7.5, but we don't want that. It's also equal to, negative 7 and 1/2. But we really don't want decimals, and we really don't want mixed numbers. We want the improper fraction as our answer. All right, let's do one more. Okay, so this time we have an x and a y, and boy golly, do we have a doozy of a problem. So let's take my own advice here, and let's build nests for all of our variables with parentheses, just some empty parentheses here. And then after we do that, then we'll go back and fill them in a little bit. Okay, so let's see, our x is, what is our x? Our x is 2. So wherever I see an x, I'm going to put a 2. And let's see, wherever we see a y, I'll put a negative 1, like that. Okay, so hopefully I did that correctly. So remember, this division line is actually serving as a grouping symbol. It's grouping that entire numerator together, and likewise it's grouping the denominator together. Okay, so you can think about just doing the numerator all at once and then the denominator. So let's look upstairs. So remember, we have to do multiplication before we do addition and subtraction. So we'll do 5 times 2, that's 10, plus negative 1 or minus 1, minus 3. Okay, downstairs we have 4 times 2 is 8. Negative 2 times negative 1 is positive 2. So that gives me 6 upstairs and 10 downstairs. Now, unfortunately, I do have to reduce this. 6 and 10 are both divisible by 2, so this reduces to 3 over 5. And that's my final answer.